There's no excuses now. We have to do the caps. So finally all the Japanese made Panasonic capacitors have arrived, which is very good. Before I start though, I just want to see what the ESR meter readings are on my meter. So let's find it's a 1510 volt. Let's have a look. Power on. 1, 2, 3. One and test. Let's see what we get. And we get an ESR of 0.03. Looks very nice. So let's see what those cheap ones were, just to compare it. Right, over here in the box. There they are. Nope. Is that them? 100 UF. Right, here they are. Alright, so these are 1500 UF 16 volt. The cheap Chinese ones that I got. So let's plug that in. Tests. And we've got 0.12 ESR. So a big difference between the two. So I expect these Japanese Panasonics to be significantly better. Well, I doubt I'll ever have to replace them ever again. Something else will die before they do, I think. So, let's get cracking. Alright, so we got all our caps out on the bench. Just looking at these, trying to work out, these are all Panasonic. Doesn't actually have anything saying Panasonic on there. Notice some of them have an M, which might be Matsushita or whatever it's called, the other word for Panasonic. But I mean, they don't look all that much different. So I definitely know these are Panasonic though, because I bought them from a reliable source. Being Farnell Components, or Element 14 I think they're called now. So, alright, I've got the board installed on my board flipper. So let's get these caps done. Oop, bit much. Alright, obviously I'm not going to do all these because it's going to be incredibly boring to watch. So I'll just do a couple. Start with the top left, work our way down. So we're 6.3 volt, 1000 UF. And they are here. So let's go. Alright, 1000 UF, 6.3. 1000 UF, 6.3. Alright, bit of flux on there. Let's see if we get a bit of solder. Try a bit of a trick. Temperature's right. And this board, I wonder if it's solder-free solder. Oh, not solder-free. Lead-free solder. It may be actually. Okay, let's bump the heat up then. We'll go 400, which is the tip burning out range of temperature. But what else can we do? Yeah, that hasn't even started to melt. I'd say that's probably lead-free solder. So wait for the temperature. Looks like it's right now. There we go. Yep, that's what it was. So that comes out now. Come on, just wiggle, wiggle. You're just holding on. Come on, let go. Yep, there we go. Look at that, it's all popped out at the bottom. Alright, let's get those holes cleaned up and the new one in. Desolder braid. I wonder if I still got the old solder sucker. Yeah. No, I reckon I got rid of it when I got my soldering gun. I'm just gonna get my desoldering gun. Be right back. Alright, just heating up my old desoldering gun. Let's go a bit hotter. .405. 300. Not ready. Let's just see if we can suck it as it is. Yep, that hole's clear. That hole is all gunked up, so I'm just going to add some solder. Let it get in there. Okay. Alright. Beauty. That's what we wanted. Turn it off. So, yeah. It's really bad seeing it. There we go. Solder's out. Took us 5 minutes just to do the first one. So, alright, we'll just get a cotton bud and clean that up. There you go. Come on, focus. There we go. 2 nice clean holes. Alright, 1000 by 6.3. Up there. Make sure the positive is in right. Alright, we'll just use a bit of tape. Hold that there. And we don't need 400 degrees. Done. Snip it. There we go. First cap replaced. How's that? Alright. So I'm just going to record doing these anyway. So if you're not interested to watch a heap of capacitors being replaced, then just skip ahead to the next part. So I'm just going to put some music on now. So if you want to keep watching, it's your choice. If not, I'll see you shortly. Says weight. Still got a bit of a thing in there. This side. It's 1500. Look at that, that's bulgy. But one of these. What is that? 6.3 2200. bit stubborn. Seems a crap. Yeah, desoldering lead-free solder, but soldering on back up. Got one hole right, just the other one. Why are you so stubborn? Look out. Crap. You're kidding me. Freaking pain in the ass sometimes. Alright, let's try this side. 1, 2, 3, 4, 5. Nah. This hole's not clearing. So I'm just going to do it the other way, which is heat the leg up as I put it in. Hopefully that'll just carry the solder as it moves through. Make sure it's the right size. 2200 by 6.3 Rubicon. These ones actually look alright. I'll replace as many as I can anyway. The only ones I couldn't find were these guys at the same value. Just don't seem to make them anymore. That's where they all look alright, so if we have stability issues we'll replace them if needed. Alright, let's get this in. Oh, that's actually starting to melt the freaking paint on there. Yeah, I hate that free solder. Come on, what do you want? I may have to use a heat gun, which I don't want to do because it affects the surrounding area too much. Turn up the heat. How high can this thing go? 480. Oh, just do 430. Try that. Give it a second to warm up. You can see the soldering tip oxidizing with the lead solder. Unfortunately, I don't have any flux that goes this high temperature, so fingers crossed. It's like it's not, the solder's not melting, which is bizarre. This is screwy. Alright, let's try it. Let's go all out. 50, 60. I don't really want to do this for too long, it's not good for the tip. But so anyway. 80. Yes, we got it. Let's turn that back down before I burn it out. 420. 420. Alright. Let's clean that up now. It's time for a new cotton bud, I think. Okay, nice and clean. 2200, 6.3 volt. 6.3. Ooh, it's a bit hot. Let's cool that down. Not soldering properly. Actually, I probably should have left the flux on there till after. Oh well. Let's get that balls of solder. That's a terrible soldering job, Michael. Let's get that down. Gravity assistance. That's better. Alright, shall we do next? We've done that one, but so we'll see what few to go. These two. Alright, 420, that's right. One out, and the second one, I can see that. Let's go up. Three. That's bizarre, that solder won't stick to the... I don't know what kind of old solder they use, but it's really stubborn to stick to. Yeah, man. Something about those holes. I think it must be. I think I've worked out what's going on. On the positive side, there's a lot of copper on the board, and that is sinking the heat away. So I'm just going to have to. Yeah, I'm just going to have to keep the heat on it for longer and probably turn the heat up. Yeah. It's funny because up the top there's each one of those comes off really easy, but the bottom one's on the square pad. Yeah, not so much. Those are the ones I'm having trouble with. Anyway. I've actually in the past used a little drill bit just to be lazy, but you risk damaging the via if you do that. So it's only for mucking around if I do that. I can see a little hole in there, but it's not quite big enough. Gosh, man. Man, this is real pain in the butt. I don't know, just to hold the heat on there a bit longer. We're at 10 seconds instead of 5. This thing's blocked actually. Like, these things are a pain in the butt. I can't really tell. Yeah, it sounds like it's sucking. It's actually not getting any better. What do you think? Heat gun? Or 450. So I just use the heat gun just to get a bit of heat. I don't know if you can see it, there's like a huge wad of copper, obviously for all the current flow. And it's obviously sinking all the heat away, which is the main problem here. You bastard. Alright, be right back. Alright, this is the way you shouldn't do it. I don't recommend you do this. But just get a drill bit with the same diameter. Carefully. Gently let it pull that solder out. 220, 6.3. I keep feeling that the soldering iron actually gets stuck onto what I'm soldering, so it's literally all this copper area wicking all the heat away. The only way to really combat that is to up the temperature. I'm not really happy with that. I'm just going to wait for that to cool down a bit. Go up to about 390, I think. Better. Much better. Cool. Probably that one. Wow, a few to do today. Let's do this guy. To what is that? 1200 16 volt. That's 220. 1000. Another 220. What is that one? 12. I don't reckon I got that one actually. Or it's possible I've ordered it and it hasn't arrived yet. They tend to do that, split the order up. Oh, I'll leave that guy. Let's do these two. No, you can't even see, sorry. Talking about this one, I don't have this one. So, place this one, that one, keep going around. One, two, three, 4, 5, 6, 7, 8, 9, 10. One, two, three, 4, 5. 1, 2, 4, 5. And again, the square pad, the heat being sunk away. Yeah. Try one more time. not use the drill bit again. So close. Come on, anyway. Damn you. What are we gonna do? Let's get some heat on it. Or we'll do it this way. This will be quick. Oh, I started to melt something, some plastic there for... Ooh. Whoops. Oh, wow, that's really hot. Let's pull this one out too. See, that doesn't look like it's touched that big bit of copper, so it might just be alright with the desolder. So we'll try. Right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Beauty. That one came out easy. So it is that copper. Right. So just confirm those were both 6.3 2200s. Yep. Put them in the holes. That one is a little bit stubborn, so let's drill it out. There you go. It's good just to get that little burr out. It's a pain in the ass. See better. And 2200, 6.3. That's probably the last one of these. Yay. I need a bit more tape. Okay. Replace these guys, all of them, apart from these ones which I can't get. All the bulging ones. Alright, very nice. Here's all the old ones. Now I'm just going to clean all the flux off, then wash the board down with a bit of electrical cleaner, just in case there's any bits floating around that might short things out. And that's it. So I'm sure as exciting as it is watching me clean flux off a board, I'll see you in a minute. Flux is all wiped off, so give it a bit of a wash. Okay, so we've got all our caps replaced. Now we need to put a heatsink back on and sort out a heatsink cooler for the CPU. So let's get to it. Okay, so this is the original cooler, but it is in a terrible state. I tried everything to clean it up, but I realized even if I acid dip it or whatever, trying to properly clean it out in between the fins is going to be near impossible. With everything, all the nickel plating flaking off, and all these fins are nickel plated as well, which means that is occurring inside the heatsink also. So I've decided not to stick with the original heatsink. I did have a quick look to see if you could get a replacement, and as I thought, you can't. So this one has a heat spreader plate, 2 heat pipes attached to that, and those heat pipes go up to the top. They wick the heat away into this top plate, and the top, or the fin stack combined, gets the heat off. So this is like an earlier design of heat pipe cooler cube thing, kind of like a server type cooler, I call it. So I've also got these things, which are very similar, and in my opinion they're probably slightly better. 3 heat pipes instead of 2, and they are bigger heat pipes. The cooling area is probably slightly smaller, but also you'll notice that the heat pipes directly touch the fins in 3 rows on each side. So I think this would be slightly better, slightly more efficient at cooling. A few of these. So the only trick is I need to make a bracket up, which shouldn't be too hard because I can just unscrew these here, make some aluminium strips that end up sitting about the same height, because the way it attaches, these spring, well, it kind of has like a spring effect. It's not an actual spring. When you tighten those down, it puts spring tension usually there and there. So if I can make it so that, yeah, you know what I mean. Make a custom bracket. So yeah, I've got a couple of these. This one's got a bit of corrosion on it. It's been sitting around. It's one of the dirty ones. I got 2 others over somewhere, so I'll find the best one, clean it, and make a bracket. So let's get started. Ugh, not good. Just missing that. Okay, while that dries in the sun, let's go down a level to the metal. Let's have a look. So I've got to get same thickness as that, but it's about a centimetre wider. So let's go to Bunnings.